Welcome to the law of sines. The only sign I care about, the bat signal.
First thing we're talking about is the law of sines. That says the ratio of the length of a side of a triangle to the sine of the angle opposite that side is the same for all sides and angles in a given triangle. So the first thing I want you to notice is that this is not a right triangle. Now today, what we're going to be dealing with, the law of sines and the law of cosines, these are going to be two different methods for finding missing sides and angles of triangles that are not right. Because we know how to solve for missing sides and angles in right triangles. We just use the trig ratios that we've been talking about, sine, cosine, and tangent. Here, the law of sines lets us solve for missing sides and angles in non-right triangles. So in this particular triangle down here, I want you to note that the side opposite angle A, we're denoting as lowercase a. The side opposite angle B, we're denoting as lowercase b. And the side opposite angle C, we're denoting as lowercase c. So what the law of sines says is that I can take the sine of angle A and put it over the measure of the side opposite that angle, which is lowercase a. That ratio is going to hold up for all angles and sides in this particular triangle, meaning the sine of A over A is equal to the sine of B over B, which is equal to the sine of C over C. That is the law of sines. Now let's talk about finding a missing side or angle in a triangle. So to find a missing side or angle in a triangle, you now have three options. And we talked about this earlier. If you are given a right triangle and you're trying to find a missing side or angle, just use your trig ratios. Sine of A is equal to opposite over hypotenuse. Cosine of A is equal to adjacent over hypotenuse. And tangent of A is equal to opposite over adjacent. Also, don't forget, if you're trying to find the missing side of a right triangle and you're given the other two sides, you can always use the Pythagorean theorem too. But if you're given a non-right triangle and you're trying to find a missing side or angle, you can use either the law of sines or the law of cosines. And it depends on what you're given. So you're going to use the law of sines if, in your non-right triangle, you're given two angle measures and one side length. Or if you're given two side lengths and the angle measure opposite one of those given side lengths. That is when you use the law of sines. You're going to use the law of cosines if you're given two side lengths and the included angle measure. The angle measure between the two side lengths that you're given. Or if you're given all three side lengths in a triangle. That's when you use the law of cosines. So make sure you memorize when to use the law of sines and when to use the law of cosines.
Listen up, kids. Superman sucks. It's example time.
Now example 1 says find the measure of segment AB. Round your answer to the nearest tenth. So this question is asking us to find a missing side length of a triangle. So the first thing we should decide is, are we going to use a trig ratio, the law of sines, or the law of cosines? Well, based on our chart before, we see that we have a non-right triangle, which means we're not going to use a trig ratio, and we're given two angle measures and one side length, meaning we need to use the law of sines. So remember, law of sines says I take the sine of an angle over the side opposite, set it equal to sine of another angle over the side opposite. So the way I set up my law of sines is my first ratio, I make sure that I'm given both the angle measure and the side opposite. So my first ratio is going to be sine of A over the length of the side opposite, the measure of segment BC, because I'm given both of those measures. Now my second ratio, I need to make sure I include what I'm trying to find. So here I'm trying to find the measure of segment AB. So my second ratio needs to be the sine of the angle opposite that, so the sine of angle C over the measure of segment AB. Now I just plug in what I know. I know the measure of angle A is 97 degrees, that goes in here. I know the measure of segment BC is 16 inches, that goes in here. The measure of angle C is 21 degrees, that goes in here. And the measure of segment AB is what I'm trying to find. Now all we have to do is solve for the measure of segment AB. So how do we do that? Well, we have a proportion. We have two ratios set equal to one another. And the way you solve a proportion is you use the cross product property. We have to cross multiply, set the two products equal to one another, and solve for the measure of segment AB. Now, how do I get the measure of segment AB by itself? Well, I just divide both sides by the sine of 97 degrees. And when I do that, these cancel out. And on this side, I just need to plug this into my calculator. Make sure you put parentheses around your numerator. And when you press enter, you need to round it to the nearest tenth. So you get that the measure of segment AB is approximately equal to 5.8 inches.
I'm busy fighting. You try.
Okay, we are again given a triangle and we are trying to find a missing side length. So we need to decide which method are we going to use. Are we going to use a trig ratio, the law of sines, or the law of cosines? Well, in this particular figure, we are given a non-right triangle, meaning we should not use a trig ratio, and we're given 2 angle measures and 1 side length, meaning it's going to be the law of sines again. So how do we set up our law of sines? Well, remember, law of sines says you take the sine of an angle over the side opposite, set it equal to sine of another angle over the side opposite. And the way I set this up is in my first ratio. I want to make sure that I'm both given the angle measure and the side opposite. So I'm going to take the sine of y over the measure of segment xz because I'm given both of those measures. In my other ratio, I need to make sure to include what I'm trying to find. I'm trying to find the measure of segment yz. So I need sine of angle x over the length of the side opposite, the measure of segment yz. Now what I can do is plug in what I know. I know that the measure of angle y is 28 degrees. That goes in here. I know the measure of segment xz is 6.2 feet. That goes in here. The measure of angle x, I don't know. The measure of segment yz, I'm trying to find. Oh, well, I need to figure out what this angle measure is. Oh, I can do that. I just take 180 degrees, subtract 117, subtract 28, and I get that the measure of angle x has to be 35 degrees. So I can take that now and plug it in here. Now all we have to do is solve this proportion. How do I do that? I use the cross product property. I just multiply across, set the 2 products equal to one another, and solve for the measure of segment yz. Well, to get the measure of segment yz by itself, all I have to do is just divide both sides by sine of 28. And when I do that, on this side, they cancel out. Over here, I make sure to put my numerator in parentheses, press divided by, and then plug in sine of 28 to my calculator. Make sure my calculator's in degree mode, not radian mode. Press enter, and I get that the measure of segment yz is approximately equal to 7.57 feet if we're rounded to the nearest hundredth of a foot. Now, example 2, we want to find the measure of angle B and round your answer to the nearest degree. So this time, we are trying to find a missing angle measure instead of a missing side length, but it still works the same way. Our first step is to determine, are we going to use a trig ratio, the law of sines, or the law of cosines to find our missing angle measure? Well, we look at our figure over here, and we see that our biggest angle here would be 83 degrees, meaning that this is a non-right triangle, so we're not going to use a trig ratio. The next thing we look at is, what are we given? We're given 2 side lengths, and we're given an angle measure opposite one of those side lengths. Because of that, we can use the law of sines to solve for our missing angle measure. So how do we set up our law of sines? Well, remember, law of sines is just sine of an angle over the side opposite is equal to sine of another angle over the side opposite. And the way I set this up is in my first ratio in my law of sines, I want to make sure that I have both the angle measure and the length of the side opposite. So in this particular figure, I have the measure of angle A and I have the length of the side opposite. So my first ratio is going to be sine of A over the measure of segment BC. In my other ratio, I need to make sure to include what I'm trying to find. I'm trying to find the measure of angle B, so I need the sine of angle B over the length of the side opposite, the measure of segment AC. Now I just plug in what I know. I know the measure of angle A is 83 degrees, that goes in here. I know the measure of segment BC is 34 kilometers, that goes in here. I'm trying to find the measure of angle B, so that just stays sine of B, and I know the measure of segment AC is 25 kilometers, so that goes in here. Now I have a proportion that I can solve for B. So how do I solve a proportion? I cross multiply. I use the cross product property. So I'm going to cross multiply, set the 2 products equal to one another, and solve for B. So how do I solve this for B? Well, you can't just divide both sides by 34 sine. It does not work like that. You can divide both sides by 34 to get sine of B all by itself, which is what we're going to do. Now, how do you get rid of sine? Well, to cancel out a trig function, you have to take the inverse of that trig function on both sides of the equation. So I'm going to take the inverse sine of both sides of the equation. The reason I do that is because the inverse sine of sine, those 2 things cancel each other out. And on this side, I just plug this into my calculator. The inverse sine of 25 sine of 83 degrees, then press divided by, then 34. Make sure to close my parentheses, press enter, and I get that the measure of angle B rounded to the nearest degree is approximately 47 degrees.
Justice. You try.
Okay, doing the same thing. We're trying to find a missing angle measure in a triangle, meaning we need to figure out, are we going to use a trig ratio? Are we going to use the law of sines or law of cosines to help us find this missing angle measure? Well, we look at our figure and we see that our biggest angle measure is 123 degrees, meaning that this is a non-right triangle, so we can't use a trig ratio. So it's either going to be law of sines or law of cosines. So we look at what else we are given. We're given 2 side lengths and an angle measure opposite one of those side lengths, meaning we can use the law of sines to solve for our missing angle angle measure. So how do we set up our law of sines? Well, remember, the law of sines is sine of an angle over the side opposite is equal to sine of another angle over the side opposite. Now remember, when I set up my law of sines, I want my first ratio to have both an angle measure and the length of the side opposite. I want to use both of those given measures. So where are we given that in our figure? Well, we're given the measure of angle R and the length of the side opposite, the measure of segment PQ. So that's going to be my first ratio. Sine of R over the measure of segment PQ is equal to, now which angle are we trying to find? We're trying to find the measure of angle P. So it'll be the sine of angle P over the length of the side opposite, the measure of segment QR. Now we just plug in what we know. We know the measure of angle R is 123 degrees. That goes in here. The measure of segment PQ is 11 centimeters. That goes in here. The measure of segment QR is 7 centimeters. That goes in there. And we're trying to find the measure of angle P. So that just stays sine of P. Now, how do we solve this proportion? We use the cross product property. We just have to multiply across, set the two products equal to one another, and solve for P. So how do we solve for P now? Well, we need to get sine of P by itself. So we have to divide both sides of the equation by 11. And when we do that, the 11s over here cancel each other out. And on this side, we're just going to leave this 7 sine of 123 over 11 for right now. Now to get P all by itself, we have to get rid of this sine. To get rid of a trig function, you need to do the inverse trig function to both sides of the equation. So I'm going to take the inverse sine of both sides of the equation. I do that because over here, the inverse sine of sine, those two things cancel each other out, and we're just left with P. On this side, we have to plug this in our calculator. We're going to press second sine, or the inverse sine of 7 sine of 123. Divide that by 11. Make sure you close parentheses at the end of your inverse sine. Press enter, and you should get that the measure of angle P is approximately equal to 32.256 degrees. Now, example 3 says solve each triangle. Round angle measures to the nearest degree and side measures to the nearest tenth. So anytime you see solve each triangle, what that means is that you need to find all the missing angle measures and all the missing side lengths in a given triangle. So to solve this particular triangle, we need to find all the missing angle measures. So that would just be this angle right here, the measure of angle Y. And we need to find all the missing side lengths. So which side lengths are we missing? We're missing the measure of segment WY and the measure of segment XY. So in order to solve this triangle, we need to find these three measures. So let's start with the measure of angle Y. In order to find the measure of angle Y, well, this is pretty easy. We know that by the triangle angle sum theorem, the sum of all three interior angles of a triangle must add up to 180 degrees. So to find the measure of angle Y, we're just going to take 180 degrees and subtract the measure of angle W and the measure of angle X. So what's 180 minus 32 minus 71? That's going to give you 77 degrees. So that would be the measure of angle Y. Now let's find the measure of segment WY. So how do we find a measure of this segment? Well, in order to find a missing side length or angle measure in a given triangle, we have three different methods to choose from. We can use a trig ratio, the law of sines, or the law of cosines. Now, because this is not a right triangle, we're not going to use a trig ratio. Instead, we got to choose between law of sines and law of cosines. So what are we given? We're given three angle measures and a side length. Well, if you take a look at our chart, you know that anytime we are given two angle measures and a side length, we're going to use the law of sines. So it would make sense that if we are given three angle measures and a side length, we could still use the law of sines. So how do we set up the law of sines? Well, remember, law of sines is just sine of an angle over the side opposite is equal to sine of another angle over the side opposite. And in my first ratio, I'm going to have sine of an angle over the side opposite. And I want to be given both the angle and the side opposite. So where are we given that in our figure? Well, angle Y, we are given that measure, and we are given the measure of the side opposite that, the measure of segment WX. So that's going to be my first ratio. Sine of Y over the measure of segment WX is equal to, and then in my other ratio, I need to make sure that I'm solving for one of my missing side lengths. Well, yeah, I have two missing side lengths here. So I guess it doesn't matter which side length I solve for first. I'm going to solve for the measure of segment WY here. So my second ratio then is going to be the sine of angle X over the measure of the side opposite, the measure of segment WY. So I have set up my law of sines, my proportion. Now all I have to do is plug in what I know. I know the measure of angle Y is 77 degrees. That goes in here. I know the measure of segment WX is 8 feet. That goes in here. I know that the measure of angle X is 71 degrees. That's going to go in here. And the measure of segment WY stays the measure of segment WY. Now I just need to solve this proportion and figure out what the measure of segment WY is. So how do I do that? I use the cross product property. I cross multiply and set the two products equal to one another and solve for the measure of segment WY. So how do I get the measure of segment WY by itself? I divide both sides by sine of 77 degrees. When I do that, over here, these cancel each other out, and I get that the measure measure of segment WY is equal to, and then on this side, I just plug this all in my calculator, and I get that the measure of segment WY is equal to approximately 7.8 feet if we're rounding to the nearest tenth of a foot. So now I can plug that in my figure over here, and now I can find my last missing side length, the measure of segment XY. So how do I find this side length? Well, I'm going to do it the exact same way. I'm going to set up my law of sines so that I have sine of the angle that I was given in the beginning, sine of Y, over the segment opposite that I was also given, the measure of segment WX, and set that equal to, this time, the angle opposite, the side length we're trying to find. So sine of angle W over the length of the side opposite, the measure of segment XY. Now what I can do is plug in what I know. I know that the measure of angle Y is 77 degrees. That goes in there. The measure of segment WX is 8 feet. That goes in there. The measure of angle W is 32 degrees. That's going to go in there. And then the measure of segment XY is what we are trying to find. So that just stays XY. Now I just need to solve this proportion in order to find the measure of segment XY. So how do we solve a proportion? We use the cross product property. We multiply across, set the two products equal to each other, and solve for the measure of segment XY. So how do I do that? I just divide both sides by sine of 77 degrees. When I do that over here, these cancel each other out. On this side, I just plug this in my calculator, and I get that the measure of segment XY is approximately equal to 4.4 feet when we round that to the nearest foot. And when I plug this in my figure over here, I see that I now have all angle measures and all side lengths. So I have solved my triangle.